want the area of space, just multiply the height and base. But if the perimeter lets you down, add up the size all around. Now with the triangle, you cut the base in half. Then multiply the height, you're gonna pass the test. Now don't forget you got to always try your best. We're proud of you, we're proud of you.
That's right. I'm proud of you guys. Welcome to the Kearney Math Show. Thank you all for tuning in. On today's episode, we are going to be featuring mini lesson 6. And so before we get started, mini lesson 6 is about cross sections. So before we get started, go ahead and write at the top of your paper, and I put a little entry number up there, so you just got to fill it in. This is entry number 7, and read our learning goal. Entry number 7. And our learning goal is that by the end of today, I want you to be able to visualize what happens when you take a 3D figure and you slice it and what shape appears. And that is called a cross section. So before we get started, there are 5 really important vocabulary words that you're going to hear Miss Kearney say a lot today when you come to my station. So I want to go ahead and get those vocabulary words down so we can see how to do this with using these vocabulary words. So the first one is prism. Now, some of this is a review. Can you think of what makes a prism in comparison to a pyramid? We've been talking a lot lately about the difference between a prism and a pyramid. What does a prism have that makes it a prism? Okay, so for me, I know that it's a 3D figure that has a base that repeats itself. So for example, if it's a rectangular prism, the base is a rectangle that repeats itself. If it's a triangular prism, the base is a triangle that repeats itself. So a 3D figure that has a base that repeats. Okay, how is that different than a pyramid? We know a pyramid is also a 3D figure, and it may have even the same base as a prism. But what is different? That's right, it comes up to a point. So a pyramid is also a 3D figure that has a base. And the base actually comes, you have one base on the bottom, and then it comes up. It connects to a point. Has a base that connects at a point. Okay, so a prism, 3D figure that has that base that repeats. A pyramid has that one base, but then the sides come up to a point. So today we're going to be talking about something called cross sections. And you may have seen this on your benchmark and wondered what in the world it is. So that's what we're going to be doing today. So a cross section is if you take a 3D figure and you slice it. So just imagine that you take a 3D figure and you just cut it in half and you open it up and you look on the inside. That a cross section is that 2D shape that is on the inside of that 3D figure after it has been sliced. So a cross section is a 2D shape that results from slicing a 3D figure. So if you were to take a 3D prism or pyramid or anything and slice it open, what 2D shape do you have on the inside? So you're going to actually get to visualize what this is when you come to my station today. So the next thing is a lot of times today, Ms. Kearney is going to ask you to slice something parallel to the base or perpendicular. So let's talk about the difference between parallel and perpendicular. So if you can think about take your arms and see if you can make 2 parallel lines with your arms. What does it look like? What do you notice about those lines? When I make parallel lines, I notice that they don't ever touch and they're always the same distance from each other. So parallel lines, always the same distance apart and never touching. They never touch. So when I say slice something parallel to the base, I mean I want you to slice something that's the same distance from the base and will not touch the base. It won't go through the base. Okay? Now, sometimes today I might say slice it perpendicular to the base. So perpendicular is kind of the opposite of parallel. Perpendicular actually slices through, and it slices and it creates a right angle. So quickly, let me go to the side. We have parallel. They never touch. And perpendicular does actually the opposite. We have a line, and we take another line and we slice exactly through it so that it creates a right angle. So perpendicular creates a right angle by intersecting. So two lines that intersect and they create a right angle. Okay? So these are super important. When you come to my station today, I want to be able to ask you what is parallel, what is perpendicular, and you should be able to tell me. Okay? So we're not going to actually go through the rest of this mini lesson right now because I want you to be able to visualize what these things are when you come to my station. So we're going to just pause this part. And what I want you to do is I want you to flip your paper over to the back. Okay? And so while you're waiting to come to my station today, there might be some time that you can work on the back practice. Say when this video is over and you're waiting for the stations to rotate, you can go in and get started on the back. And what I want you to do is when you are going through this review, what I noticed on your quiz on Friday is that you guys know surface area and you know volume, but when you put them together, sometimes we get confused. So what I'm going to do is I'm going to give you some steps that I want to see that you do as you solve your review problems. So I'm on the back and I want you to write these 3 steps down. Okay? The first step, when you solve these, I want you to first decide if it's a surface area or volume problem. Surface area or volume. Okay? Next, after you decide if it's a surface area or volume, I want you to write the formula that you're going to need. Or formulas. And then the third step, so you're going to read the problem, decide if it's a surface area or volume problem, write the formula, and then you're going to solve using the formula. Okay, so I'll go through one with you really quickly. So let's do number 3, using those 3 steps. Number 3, it says find the volume of this trapezoidal prism. So first, I know it's a volume problem. And I know it's the volume of a prism. So step 1, I've decided it's a volume problem. Step 2, I'm going to write the formula. So volume of a prism, and you can use your foldable if you've already made it. If not, you can use your notes. Volume of a prism, big B times H. Big B is the area of the base. So we've got to find the area of the base. And height, H is the height of the prism. So step 3, now we're going to solve using the formula. So when you look at this figure, what shape is a prism? So what shape is being repeated? I see a trapezoid that's being repeated. So my big B is going to be a trapezoid. So how do you find the area of a trapezoid? So I'm going to do B1. So B1 would be maybe 5 plus my B2 down here at the bottom is 15. So base 1 plus base 2 times the height. How tall is that prism? The trapezoid. So times the height, which is 12, and then divide by 2. So that is, I'll put in my calculator, 240 divided by 2, which is 120. Okay, what is my H? So how far back, how many trapezoids would I stack until I got to the back? That would be this right here, which is 24. So now I'm going to do big B times H, which is 120 times 24. And I get 2,880 inches cubed because it's volume. So step one, come back up here. We decided if it was a volume problem or surface area. It's volume. Step two, we wrote the formula. Step three, we solve. For every problem, I want to see that you're going through and first deciding, is this volume or surface area? And use those formulas. All right, guys. So if you are finished before it's time to rotate, you can use this time now to work on your study guide. And we're going to do some cross sections when you come up to my station. Good luck, guys. Peace out, Rainbow Trout. Love you, mean it.